Good morning, all of you. And today's we will discuss about the new topic, that is statistical graphics. And this question is asked so many times in the IQT examination. So today's we will discuss about which type of graphs are using into the SCI. So statistical graphics means it is the data presented in the graphical format. Just like if you have a raw data and if you want to present your data in a short time, so that we will use to the graphics. For example, for the marketing strategy, for the data analytics. So many places we are using the statistical graphics. So well designed statistical graphics, also referred to as a chart, graph, consist of complex ideas communicated with the clarity, precision, and the efficiency. So it is also give the viewer the greatest number of ideas in the shortest of time. So mentioned that is taking very less time and very less space. So with the least possible clutter. So it will also induce the viewer of think of substance, not techniques or methodology. It will provide coherence to the large amount of information, and by trying to them together and meaningful way. And it is also encourage data comparison of its different piece of by the eye. It is also a well-designed statistical graphics display also avoid distortion by telling the truth about the data. So that is the overview about the statistical graphics. What are the use of the statistical graphics? Basically the main use of statistical graphics to reserve for material that is rich, complex, or the difficult. So statistical graphics is also reserved for the large set of data with real variability. For example, just in your company, you have a profit or loss. So how much type of how many profit during the per year, per day, per month. So that is represented by the graphs. So the power of graphics should not be wasted on simple linear change or situation in which one or two number would summarize the result better. Tuffet 1983 says that tables usually outperform graphics on a small data of 20 or the fewer number, or when data sets and are non-comparative of or highly labeled. Okay, so that is a component of the statistical graphics. So basic thing is that here is a title, here is the y scale, and that is the x scale. That is the y-axis, x-axis, and it's also the represented the data area, and that is represented the ligand. Okay, so most statistical graphics have at least two axes, x-axis and y-axis. Okay, and two scales, x scale and y scale, area to be presented in a data. That is the data area which is represented the data, and sometimes a legend or the key is also are presented in this figure. So pie chart are the exception of this general rule. In the pie chart, because pie chart is basically belongs to the circle, and we have divided into the according to this. So pie chart is not belongs to that type of statistical graphics. So some of the guidelines of the graphic component include the following. What kind of guideline we have to follow to make the statistical graphics? First is emphasize the data. So we will focus on the data. Minimize the non-data elements. Minimize the redundant element. Show also the data variation, not design variation, and provide the proper context of data interpretation. Okay, so restrict the number of possible, maximize data density, employ simple data coding scheme, avoid unnecessary emplacement of grids, vibration, ornamentation, and fill also graph available area with the data. Okay, so these are the data presentation. In the graphics statics, so avoid unnecessary embellishment. Unnecessary embellishment means that is not required data set, required area. So the eye is never absolutely still. It produces continuous light tremors that add visual acuity. So the result is that when a small pattern line, boxes or dots are viewed, they simmer to vibrate, or the vibration can be distracting. Example I listed in so these are some vibration which is not useful into the our graph. Okay, axis, there are the two type of axes are there already discussed. So value on axis should increase or they move away from the origin. For example, this is the x-axis and that is the y-axis. Okay, so we have to put data according to this axis. Okay, so use the horizontal axis to show time or cause on the event, the independent variable. Use the vertical axis y to show the cause effect, dependent variable. So when the x-axis plot time interval, the label point should represent in the end of each time interval. That is the time interval between two of them. The x-axis may also be called abscissa or category axis, and then y-axis is ordinary value of the ordinal or value of the axis. If the graphic possesses 3 dimension, the third axis is called the z-axis. Okay, reflecting the graph plane. Scale and scaling. Scales place sticks to mark scale on the outside edge of the each axis. Employ a linear axis, for example, that is the scale are there. Okay, mark scale at standard or customary interval. Start with the numerical stick with the 0, 1, 2, 3, 4. That is the scale. So keep the number of digits in the scale to the minimum. Display only a single scale on a single each axis. For large data matrix, consider displaying duplicate axis. Okay, so provide aids of scale interpretation. Provide scaling consistency across 2 or more related graphics, and also clearly label each axis in the left to right reading orientation. Okay, that is left to right orientation. Proportion is also the provide accurate proportion of the displayed surface, the data they represented. Provide proper proportion by conforming to the shape of the data, making the width greater than the height. Okay, that is a basic proportion. Lines are different types of line using in the graphs. So data line should be the heaviest. For example, that is if the line is heaviest, so it's represented the data line. Axis line should be a medium weight, extended the lines entirely around the graphics, and grid line should be very thin or absent. Okay. Labeling, employ clear, detail, and thorough labeling, or a labeling into the axis. Maintain left to right labeling, left to right reading orientation, and also integrate the labeling with the drawing. Do not curve letters to match the shape of the curved line. Use only one typeface, font and weight. For emphasis, use different type size. Do not separate labeling from the data through ruled lines. Provide information about the source of the data. So use a legend of the complicated graphics. Okay. Title means the which kind of graphs are there. So create a short. For example, if you want to prediction about to the home prediction, so that is a home prediction graphs. Okay, linear graph. So create a short, simple, clear, distinctive title describing the purpose of the graphics. Position of the title ever. Position is basically here. The title of graph. Title above, center or left line of the rectangle formed of the extended axis. Plan it fully using the mixed case or the uppercase font. Adding interpretation of the number. Display a grid on request. Permit the viewer to click on data point to display actual value. Show numerical value automatically for each point or bar. Permit the viewer to zoom in on area of the graphics. Permit the user to change the scale value. Permit toggling between the graphics and table. Okay. So they are the component of the statistical graphics, and right now we will discuss about to the types of the statistical graphics. So the first type is curves and line graph. Simply the curves are using and line graph is using. Surface chart, scatter plots, bar graph, histograms, segmented, stack bars, pie chart. So different statistical graphs are using into different way. Somewhere is using the only line graph for the linear prediction. Somewhere is using the surface chart. Somewhere using the scatter plot, for example, to the population point of view. Somewhere use the bar graph using for to increase the market step. Somewhere use the histogram. So different position we have to use to the different graphs. What is curve and line graph? Curve and line graph, it's simply display data curves or line that must be compared in a single graph. So and display no more than 4 or 5 curves in a single graph. Identified each curve or line with the adjacent label whenever possible. If a legend must be included, order the legend to match the spatial ordering of the lines. for tightly pegged curves or lines, provide data differentiation with a line coding technique such as different colors or different line composition types, highlight curves or line important in the crucial data, and when comparing actual to the projected data, use solid curve or line for the actual data or use broken curves or line for the projected data. Also, to display the reference index, if the display data must be compared or stand on the critical value. Display difference between two data set as a curve or line itself. So that is the main idea about to the curve and line graph. Second is surface chart. So surface chart is basically just like to here is area 1, 2, 3 and 4. These are the 4 surfaces are there. So order the data categorized on that. The least variable, there is the area 1 is the least variable is the bottom, and the most variable is into the top. Okay. The largest is the bottom, at the end the smallest at the top. Use different texture or shading coding scheme of the we have to coding according to the different color code. Incorporate label with the bonds. Here we have to identify the label just like to area 1, 2, 3 and 4. Scatter plots is for example, that is the scatter plot. There different scattered are there, so that is called the scatter plot. Limit use to two-dimensional display of the data. Maintain consistent scale size interval. Provide distinguishable equal size plot point. If there is more than one set of data on the plot, use different symbol or each data point. Visually distinguish point of the particular significance through a highlighting technique. For example, this is a scatter plot. If we are plot is this is a circle. If we are plot is a triangle also. Okay, so that is another graph. Bar graph is orient bar consistently either horizontally or vertical, either horizontally like this and either vertical like this. So use vertical bar when the item being counted is in the greatest interest. Use horizontal bar when the data levels are too low to highlight the information rather than the count. Use a meaningful organizing principle, non-exit. Arrange the bar so that the length of bar is in ascending or descending order. Make the spacing between bar equal to 1/2 of the width of the bar or the less. If grouping of bar are presented, leave space between the grouping only. So different kind of bar can be easily discussed. Okay, so if possible, use a pattern or color that reinforce the data. Highlights the bar representing the important or the critical data. Provide a consistent ordering for related group of bar. Display a reference index if display data must be compared to a standard or critical values. Identify each bar with the adjacent label. When a great many piece of data must be compared and considered using the histogram of the step chart. So that is the bar graph with a common origin point. Okay. Segmented or the stacked bar. So that is the advanced version of the bar graph. So order of the data categorized in the same sequences. Order of the data categorized so that the least variable it is the bottom and the most variable it is the top. For example, that is the stack. There is a 3 are there, 1, 2 and 3, 1, 2 and 3. So limit the number of segment of those that are large enough to be seen and labeled. Use different texture or coding scheme of the differentiate area with the each bar. Clearly associate label with bar or segment and place segment table to the right on the vertical chart or the above the horizontal chart. For example, that is a segmented or stacked bar. These are the 3 different color coding or scheme are there. Okay, 1, 2 and 3. Pie chart, already we have discussed about to the pie chart. Pie chart is basically using for 100% part. Okay, for example, in our population, in 140 crore population, how much are different regions are there. So which religion have a percentage, what is the what are the population of the Hindus, what are the population of Muslim, what are the population of different other castes, Sikh, Isai. So they must add, it is represented the total 100%. So it is represented the circle bar, and there are basically we are using 5 segmented or the 4 segmented or 6 segmented. Here the 1, 2, 3, 4, 5 or 6 segmented are there. Okay. So each segment should take at least 5%, 18 degree of the circle. Okay. So place the largest segment starting at 12. If there are the largest segment, so then we are using on this 1. Okay. 1 is the largest element. For example, 50%, for 30%, 20%, 20%, and 10% also. Okay. So place the lead segment directly labeled, each segment in the normal reading orientation. If leaders are for label in a small segment are necessary, orient them in the few angle as possible. So that is include number with the segment labels to indicate percentage of the absolute value. So texture or column coding is selected for the segment should not be emphasized one segment over another. Highlight segment requiring particular emphasis through a contrasting display technique or by the exploring it. Never tilde pi. Okay, never tilde pi. So that is 1, 2, 3, 4, and 5. So these are the 5 segmented pie charts, and it's represented the 100% population, 100% of any values. Okay. So today, so how can we determine which graph are using on the which place? Okay. So determine what kind of information is most important for the viewer to extract. Choose the type of the graph best suited for presenting that kind of information. So if we are using the proportion field, okay, proportion is if we are using with scale, without scale, if we are using the comparison, or we are using the changes. So if we have a proportion, the best graph is the line graph with scale value. Okay. If we don't have a scale value, then we will using the segmented bar. If we are using for the comparison, then also we are using the bar graph. If the changes are occurred, so then we are using the line graph. Same like as here, proportion, bar graph, pie charts, segmented, and also the bar graph, segmented bars, and the with pie chart, that is a scale value. Poorest form without scale, that if we are using the bar graph, so we can't identify which value are going. Comparison in pie chart we cannot identify in the comparison, and also the segmented bar is not using for the changes value. Line graph is with scale and without scale, that is the poorest form of the any kind of graph. Next is the flow chart. So already we know about the flow chart. Flow chart is it means it is flow of your process. Okay, which kind of process you have to follow. For example, if you have an algo about any identifying the bubble sort, identify the any sorting techniques, so there is a flow chart. For example, just to prepare the tea, so that is also the flow chart. Just okay, so it is follow some logical order and it is represented into the step form. Follow some logical order, minimize a path link. Okay, so orient the chart following common flow chart, reading conventions such as left to right and top to bottom. Okay, so that is the part. Follow common flowchart coding convention to distinguish elements. Also use arrow. Different type of arrows are using to use arrow to conventional way of indicate directional relationship. For example, that is a flowchart that is also using different type of boxes are there, that is representing the it's representing the start, it's representing the input value, that is the comparison value, and that is also the end. So use arrow in the highlight element requiring particular attention through a contrasting display technique. Require only one decision at each space, and be consistent in all option ordering of watering. So that is the step of the flowchart. So thanks to listen this lecture. If you have any query, so just ask me from a mail ID guptapradeep@akgec.ac.in. Thank you.